Hello everybody, I'm Mike Home, Country Manager and Tracker Technician for Anti-Solar Australia. After understanding the design principles behind the AT Spark, I will now walk you through the practical application of the design concept. We're here currently on a 500 megawatt utility scale solar farm, where we will be showcasing the AT Spark, Anti-Solar's newly developed single axis tracker. When designing the AT Spark, we asked ourselves two key questions. What will make it the optimal choice for large-scale solar farms? And what will set it apart from other systems? The answer to our questions lay within the redesigning of two core components, the torque tubes and the bearing housings. First, let's take a look at the spine of the tracker, the torque tube. The torque tube serves as the primary load bearing and transmission component, subjected mainly to bending moments and torsional forces. The AT Spark faces the demanding challenges of larger modules, higher wind speeds, and greater spans. To handle these forces, our torque tubes must feature a strong load bearing capacity, with equal importance placed on its ability to resist both bending and torsional forces. Here you can see our first key structural update, the octagonal torque tube. By precisely optimizing the angle of the octagonal cross-section, we have greatly improved material utilization and achieved the perfect balance between bending resistance and torsional resistance. The rigid main structure of the tracker requires adjustable nodes to accommodate various deviations and errors accrued over the installation process. The second structural innovation of the AT Spark is embodied in our bearing housing, which features a dual spherical self-adaptive bearing system. It addresses two critical engineering challenges in large-scale solar farms: terrain adaptability and installation efficiency. As we can see with the inclinometer, the project site has a significant slope. For traditional trackers, adapting to such slopes requires manually, repeatedly adjusting the bearing seat angle to align the rotational center, a process that is both time-consuming and costly. In addition, it is also difficult to ensure the accuracy of such adjustments, which creates hidden risks for future operations. The AT Spark's self-developed innovative dual spherical bearing design directly addresses this challenge. Its core advantage lies in the spherical coordination between the bearing seat and the bearing housing, forming a universal rotation structure that meets the transmission needs of the tracking system. On sloping sites, the internal spherical bearing allows flexible north-south deflection, enabling the torque tube to automatically adapt to terrain variations of up to 15% without the need for manual adjustment. This means the AT Spark can passively adjust to terrain variations through its mechanical design alone. The result is significantly reduced installation stresses, improving long-term reliability of the transmission system, and enhanced structural and safety, all without additional operational complexity. In large-scale tracker projects, the bearing housing installation and adjustments have always been a highly labor-intensive task. To tackle this challenge, we redesigned the AT Spark's bearing seat with a focus on an integrated structure and simplified adjustments. The innovative Y-shaped design features a dual arc support that comfortably fits the torque tube's spherical bearing, while the central hole accommodates the synchronous shaft bearing. This combination eliminates traditional manual alignment, offering a significant time saving. Additionally, the dual arc support features vertical elongated holes. When aligned with the post horizontal holes, forms a cross-shaped adjustment mechanism. This design increases installation tolerance and simplifies alignment during assembly. The tool-free snap-fit design ensures perfect torque tube to bearing contact, preventing slippage and ensuring reliable operation. Combined with the flip-open housing, it enables easy installation and removal, significantly improving maintainability. Furthermore, we offer a high level of pre-assembly. The bearing seats, cover plates, and spherical bearings for the synchronous shaft can be pre-assembled at our factory, allowing direct on-site installation. To address the common issue of sagging in the synchronous shaft over long spans, Antai developed an improved structural design that provides continuous support to maintain shaft straightness, thereby enhancing transmission accuracy. The installation design is equally thoughtful, using a geometric fit and rotary locking mechanism. The cylindrical structure of the bearing sleeve securely engages with the bracket's sliding groove, so additional fasteners are not needed. Through these optimizations, the AT-Spark's installation efficiency has increased by approximately 25%, substantially saving labour and time costs. A flexible mechanical structure requires an intelligent control system to drive it, which leads us to our third upgrade, Antai's self-developed intelligent tracking system unit. The tracker controller unit in front of us is one of the core components of the entire intelligent tracking algorithm. Next, our R&D colleague Emmanuel will give us a more detailed introduction to this control system. Now let's hand over the floor to him.